In this section, we are going to leverage on how we can use the MAC address of interfaces to come up with an IPv6 address. This method is called the EUI-64 bits, Enhanced Unique Identifier, that's 64 bits. So in this scenario, we have two routers connected to each other. So we have this network. This network has an ID of FC01:2BAC:9A:DB:002A and double colon. So we have 4 continuous zeros. The MAC address of F0/1 is what we are seeing here, this figure here, and it's 48 bits. So how do we use this 48 bits in the 64 bits of the interface ID portion? Okay, we have repeated this subnet ID here, that's what you are saying, and because we have double colon here, we have expanded the address to have 4 consecutive zeros here. This portion is 64 bits, and that's the interface ID. So we are going to manipulate this 64 bits here to come up with an IPv6 address. This will be the final outcome of the address. But let's watch the steps. The 48-bit MAC address of this interface is going to be inserted in this field. But remember, we should have 64 bits. So what will account for the 64 bits? The MAC address will be inserted with FFFE, which is a fixed value. FFFE is 16 bits. So 16 bits adding up to the 48-bit MAC address will give us 64 bits. That is step 1. So if you look at the steps here, it says first insert FFFE in the MAC address, and that's what we've just done. So we came up with this AC501A FECD:592C. So step 1 is achieved. Step 2, flip the 7th bit. So how do we know the 7th bit? Remember, all the values here are hexadecimal, so we have to convert the first 2 digits here to binary before we can see the 7th bit. So converting A to binaries, we have 1010. C will give us 1100. So from this point, we can count our 7th bit. So bit number 1, 2, 3, 4, 5, 6, 7. This is our 7th bit. We are going to flip it. If it's 0, we'll make it 1. If it is 1, we'll make it 0. That is the meaning of flipping. So we flipped this address here, and we got 1 here. After flipping, you convert everything back to hexa. So converting 1010 back to hexa, we have our A, and converting the flipped portion, we have E. So the 2 values here will now become AE instead of AC. So that is what we brought here. So after flipping, we have this AE501A FF FECD and 592C. So we are done with the manipulation. 48-bit MAC address has now turned to this 64-bit address because we inserted FFFE and we also flipped the 7th bit. Now we have an address for the interface. So you bring the network ID, then you continue with the results of the manipulation. That's it. This method is called the EUI-64 bits. And we are not going to do this calculation. The router itself will do everything for us. We only need to understand. So now let's jump to Packet Tracer to see how the configuration looks like. So in this configuration, we are going to install a router. Then we connect it to a switch, thereby creating a network. We connect a PC to the switch. Another interface will also go to a switch, and that will also be connected to a PC. Let's call this interface Fast Ethernet 0/1, and this interface will be Fast Ethernet 0/0. Let's give them subnet IDs. So this subnet, we have two different networks or two different subnets, this subnet and this subnet. So this subnet will have an ID of FC01:2BAC:9A:DB:2A and /64, meaning we have 4 consecutive 0 that will account for the interface ID. For this network, we have FC01:9A:DB:ED. You see, the subnet ID is different from the first network. Then 4 consecutive zeros and a /64. We'll look at the MAC address of this interface here. And the MAC address of this interface will be used to generate an IP address for this interface using the subnet ID. After that, we will assign an IP address to this PC here. They'll also be automated, so they also acquire their IP address using the EUI-64 bits. So let's see how Packet Tracer will do it for us. Bring up a router, 1841 router, and pick up two 2960 switches. Connect the switches to the interfaces of this router. Let's connect some end devices. So we have our network. Open this router here and check the MAC address of interface F0/1. Enable, show interface F0/1. And this output is giving us the MAC address of interface F0/1. That is it. So let's copy it and put it on Notepad. So that's the MAC address, 64-bit MAC address of F0/1. we are going to see how this MAC address will be used to come up with an interface ID of the router. Before we do that, let's see how the configuration goes, how the command is like. So on the CLI, you go to the global configuration mode, configure terminal, then you enter the interface F0/1. Over here, you are going to enable IPv6 unicast routing, as you have seen already. Then here, you enable IPv6 for that interface. Then it's time for you to assign the IP address using the EUI-64 bits. So IPv6 address, you are going to enter the network ID as you are saying. So FC01:2B AC9ADB:2A:64, then you continue with EUI-64. After entering this command, automation will happen. The MAC address of this interface will be used to come up with an IP address for that interface. So let's enter this command in Packet Tracer and see how the IP address for F0/1 will be generated using the MAC address of F0/1. So on this network topology, we enter the CLI, come to the global configuration mode, enable IPv6 unicast routing, go to interface F0/1, enable the interface for IPv6, then assign the address, IPv6 address FC01:2BAC:9ADB:2A and /64-EUI-64-bit. You enter and you enable the interface. You activate it by typing no shut. Let's save it. So do copy run to start up config, and it's been saved. At this point, an IP address has been generated for Fast Ethernet 0/1. Let's confirm. So show IPv6 interface brief, and there we go. This is the address which has been generated for that interface. Hold on for this link local address. We'll talk about it later on. This address has been generated for interface F0/1. Let's digest on this address. So copying it and putting it on Notepad. Over here we already have the MAC address of that interface. That is what we are seeing here. So let's see how this MAC address was used to come up with an IP address. That is the last 64 bits. Remember we have a 0 here, but it's omitted because it's a leading 0. We also have a 0 here, it's omitted. So let me repeat this last 64 bit by entering the zeros which have been omitted. And we have 0, 2, 0, D, double colon, B, B, D, F, F, double colon, F, E, 0, 5, and 0, C, 0, 2. We said the MAC address was inserted with FFFE here. So let's take it out. Let's take the FFFE out. So we have 0, 2, 0, D, colon, B, D, 0, 5, colon, 0, C, 0, 2. So what are we doing? We are breaking down the last 64 bits to see if we can come up with the MAC address. So we have removed the FFFE from it, and this is the 48 bit that we are having. After that, we were told that the 7th bit was flipped. So let's see how we can locate the 7th bit. Converting the 0 to binary, we have 0, 0, 0, 0, and 2 will give us 0, 0, 1, 0. That is the 7th bit here. This one. That's the 7th bit. So let's flip it. Flipping it will give us 0, 0, 0, 0. So converting everything here back to hexa, we have a 0, and also converting everything here back to hexa, we have 0. So now the address becomes, instead of 0, 2, we have 0, 0. So 0, 0, 0, D, colon, BD, 0, 5, and colon 0, C, 0, 2. So that is the MAC address up here. So this is how EUI uses the MAC address to come up with the interface IP address. It's very simple steps. So let's continue with our configuration. So we are going to configure this interface F0/0 also with EUI, taking advantage of the MAC address of F0/0 to come up with an IP address. So let's see how the configuration goes. Same steps. Go to the global configuration mode, enter to interface F0/0, enable IPv6, then IPv6 address, network ID for that interface is FC01 colon 2BAC colon 9ADB colon AE /64 and continue with EUI-64. This command here, EUI-64, is telling the interface to use its MAC address to come up with an interface IP. So we enter and we activate the interface by typing no shut. So let's save the command and it's saved. Verification. Do show IPv6 interface brief. And there we go. F0/0 now has this address, which was generated from its interface MAC address. F0/1 also has this address. We call this the automatic assignation of IPv6 addresses, which is totally different from the manual method. Now we can come to the PCs to also assign IP addresses using the EUI-64 bits. So you open the PC, come to desktop, and IP configuration. This portion is for IPv6 and that is for IPv4. So we click on auto config and the PC has automatically configured itself. So now this is the IP address that the PC got for itself using its own MAC address. Remember, this PC also has a MAC address on its interface. So it's leveraged on the network ID, which is FC01-2BAC-9ADB:2A, and it came up with its own IP address using its MAC address. Watch here, you can see FFFE in this portion, same method. Now this time, the PC has picked a default gateway, which is the link local address for interface F0/1. This address. We'll talk about the link local addresses later on. This one, rather. So that is what the PC picked. The link local address here as its default gateway is accepted. Come to this PC and let it auto configure itself. Auto config, and this PC has also generated automatically an IPv6 address. That's what we are seeing here, using the subnet ID and also inserting its MAC address in the interface ID portion. It also chose the link local address for interface F0/0, this one, as its default gateway. Now let's see if the PCs can ping each other. So how do we get the IP address for this PC? Let's go to the command prompt and IPv6 config. That is showing us the IP configuration for that interface of the PC, and this is the IP we are looking for. Let me stretch this. That is the IP we are looking for. So let's copy up to here. Copy from this PC. We did that from this PC, and we are coming here to ping. So go to the command prompt and ping. Let's paste. In IPv6 configuration, you do a lot of copy and paste so that you don't fat finger. Enter, and there's response. Let me bring up the command again. Enter, and there's connectivity. So in these simple steps, we've been able to automatically configure the interface IP addresses for the router using the EUI-64 bits. This method is called the automation of IP address assignation. Thank you for joining us.